Hello students, as we have discussed about the coordination compounds, its types and some important terms in the coordination compounds. Let us discuss the naming of coordination compound which is recommended by IUPAC. So let us discuss IUPAC naming of coordination compounds. First, let us discuss how to name the cationic complexes or the neutral complexes. For example, a general cationic complex is represented here. Let us first, I will introduce the terms here. What is M here? M is the central metal. Central metal, that is usually transition metal atoms or the metal ions that I have represented M. That is always written, that is just after this bracket it is written. Then after the writing of central metal ion in the formula, the ligands are written as you have seen here. Generally I am representing the ligand with L and 4 number of ligands L is there. So that is in the formula, the metal is written first, then the ligand is written and the number of ligand is written with number, and after closing the sphere, then at the end the counter ion, which is actually, this is which type of counter ion here? That is a negative counter ion. When it is a negative counter ion like chloro, bromo, nitrate, in that case it will develop a positive charge on the sphere, because the negative counter ion, when it gets removed, what it develops a positive charge on the sphere. So that is, I have represented the formula here. Now how to name this complex, that we have to discuss here. First of all, while naming the complexes, you need to remember the names of different ligands. As we have ligands like H2O. H2O is called as aqua. NH3 is called as amine. And the halogens we have, that is Cl, Br. These are named as like chlorido, bromido respectively. So first of all, we need to learn the names of ligands. Central metal ion names as, you are familiar that if nickel is there, then its name is used nickel. Fe iron, Cu copper, Co cobalt. So the name of the central metal ion will be as it is the name of that element. And the counter ion will be named, if it is Cl, then it is named as, this counter ion, if it is Cl, then it is named as chloride. It should be named as iron. If it is Br, this counter ion, if it is Br, then it is named as bromide. If it is NO3, this one is NO3, then it is named as nitrate. So the counter ion should be named as it is like its ion. So first we will be discussing how these naming should be arranged. It should be arranged in the proper order, that we have to discuss. First we have to, in the case of cationic complexes, first we have to name the ligands. So which one is the ligand here? L is the ligand. So first the name of ligand should be written and the prefix should be given here depending upon the number of ligand, because here 4 ligand are there. So we have to use the word tetra. So the prefix we have to use, that is di, tri, mono, etc. for the number of ligands which is present in the complex. So in this case, on the 4 numbers of ligands are there. So we have to use word tetra. So tetra and the name of the ligand that I am not specifying here. If it is Cl, then it is chlorido. So that is tetra. Then the name of the ligand. Then we have to name the central metal ion. If the central metal ion is Fe, it should be written iron. If the central metal ion is copper, then we have to write copper. So after writing the name of ligand, then we have to write the name of the central metal ion, and then we have to name the counter ion in the case of cationic complexes. So what is the order of writing the name? That is, first we have to write the name of ligand with the suffix, with the prefix, whether it is di, tri or etc. And if it is have more than one ligand, then we have to follow alphabetic order. Then we have to name the central metal ion. Then we have to name the counter ion. So this is the order which we have to follow in the case of cationic complexes. Let us take one example for the cationic complex. Like this example, it is an example of cationic complex because here the counter ion is negatively charged ion. As you know that Cl have negative charge, that means the counter ion is negatively charged. So this is an example of which type of complex? Cationic complex. Now how to name this? As I told you the order, first you have to name the ligand. So what is the ligand? That is NH3. NH3 is the ligand. So what is the name given to this ligand? That is amine. We have to write the name of the NH3, that is a ligand, amine. But we have to write the number of that ligand. 6 amine is present. So we have to use the prefix hexa. So hexaamine. Then after ligand only we have to name the metal. That is cobalt is here. So we have to name the cobalt. Then in the Roman letters we have to write down the oxidation number of cobalt. As we have learned the method to find out the oxidation number of central metal ion. And the same method we have to find out the oxidation number. So we will be getting 3 plus 3. So we are writing plus 3 in the Roman letters. Then we have to name the counter ion. What is the counter ion here? It is chloride. But when you are mentioning the counter ion, the number of that ion is not specified. So you have to write just chloride. So what is the order of writing the names for the case of cationic complex? First ligand with the prefix for the number of ligand. Then if it is more than one ligand, we have to follow the alphabetic order. Next we have to name the metal, and in the bracket we have to write down the oxidation number of that central metal ion. Then at last we have to mention the that is a counter ion. Here it is chloride. So what is the name of this complex? That is hexaamine cobalt. Here it is have plus 3 oxidation state. So plus bracket, in brackets we have to write Roman letter 3, then chloride. So because here the counter ion is Cl, therefore it is chloride. So what is the order of writing the name? First you have to write the name of the ligand. First the number of ligand is 6 here. So hexaamine cobalt, oxidation state in the bracket, then chloride. So this is the order of writing the name for the cationic complex. Now in the case of anionic complex, little bit difference is there. That is, in the case of anionic complex, we have a cation that is written on the left hand side of the bracket. That is in the coordination sphere. It is written on the left hand side. So in the case of anionic complex, first we have to name the cation. So what is the order first? First we have to name the cation. The number of cations is not written here. Just we have to name that cation. Then we have to name the ligand. And the number of ligand should be specified. That is with the prefix mono, di, tri, tetra, etc. And if it is more than one ligand, we have to follow the alphabetic order. Then we have to name the metal. So this is the order of writing the names for the case of anionic complex. That is, first for the positively charged counter ion, second for the case of ligand with the prefix of number of ligand, and then only we have to name the central metal ion. But here when we are naming the central metal ion, one important point which we need to follow, that the metal, like if it is nickel, then its name should be end with ATE, that is nickelate. Instead of writing the name nickel, we have to write nickelate. That is for the case of the central metal ion complex. Let us do one problem, that is K3FeCN6. It is an example of anionic complex. How we identify it? Because the counter ion is positively charged ion here. So first we have to name the positive charge ion, that is potassium. As I told you, the number of counter ion is not specified in the name. So here K3, so 3 is not specified. So we are just writing potassium. Potassium, then we have to name, after the naming of the cation, that is the counter ion, we have to name the ligand. So second we have to name the ligand. But when we are mentioning the name for ligand, we have to give the prefix for the number of ligand. Here because 6 is the number of ligand, so we have to use the word hexa. And it is a which type of ligand? The name of this ligand is cyano, CYANO, cyano. And at the end we have to name the central metal ion, that is Fe here. So we have to name ferrate. As I told you, in the case of anionic complex, we have to end the name of that metal atom or the ion with the suffix ate. So ferrate. So we will be not using the word ionate here. That is wrong here. We have to use ferrate. And the oxidation number of that central metal ion should be written in the brackets in the Roman letters. So that is one of the example for anionic complex. Let us take one example of a neutral complex, that is NiCO4. In this case, the order is as it is, just first the ligand, then the central metal ion. But here there is no counter ion, so don't worry about it. Start with the ligand. So what is the ligand here? That is carbonyl. And what is the number of CO here? It is 4. So we have to use tetracarbonyl. Then nickel. Then what is the oxidation state here? That is 0 oxidation state for nickel. Why? Because CO is a neutral ligand. So oxidation state of CO is 0. And here the overall charge is also 0. So what will be the oxidation state of nickel here? That is 0. So what is the name for this compound? For this complex, it is a neutral complex. Its name is tetracarbonyl nickel 0. So in this case also, in the neutral case also, the central metal ion should be written, its name should be written as it is. Nickel as the name. So if it is Fe, we have to write as iron. If it is Cu, we have to write copper as it is. But the name end with ATE, that is only for the case of anionic complex. Now we'll be doing some examples, so then it will be more clear to you. So we'll be taking some example like CuNH3,4Cl2. As first of all, identify this one. It is which type of complex? It is a cationic complex because the counter ion is, that is negatively charged counter ion. So it is a cationic complex. So the naming, the order of naming, first ligand, that is NH3. NH3 is a ligand. What is the name given for this NH3? That is amine. But here 4 NH3 are there, so we have to use the word tetra. Then amine, for NH3 the name is amine. After the naming of ligand, then we have to name the central metal ion, that is copper. Why it is copper because it is a cationic complex. So we have to name the central metal ion as it is. And the oxidation number, when you find it out here, it is 2. So we have to write in the brackets, that is Roman letter 2. After the naming of ligand, then the central metal ion, then at the end we have to name the counter ion, which is a negatively charged counter ion. And what is that counter ion? Cl negative, that is named as chloride. I told you the number of counter ion is not specified, that is, it is not specified the number 2 here, just we need to write chloride. So that is the name of this compound. Next, this example, in this Cr is the central metal ion. There are 2 ligands, that is NH3 is also the ligand, Cl is also ligand, and there is a counter ion, that is NO3. So NO3 have one negative charge, means it should have one positive charge on the sphere. So how we name this one? As I told you, first we have to name the ligand. But when we are naming the ligand, if it is more than one type of ligand is there, then we have to follow the alphabetic order. So when you look at here, NH3, that is amine. Cl, how we name Cl? Chloro, we can name it, or chlorido. Anyone can be followed. So here Cl is chloro, NH3 is amine. So alphabetic order, which comes first? That is A comes first. So we have to name the amine first. That is about the ligands. If ligands are more than one type, then we have to name it in the alphabetic order. So amine comes first, alphabetically order A. Therefore first we have to name the NH3. So let us name for this one NH3. What is the number of NH3? 4. So we'll be using the word tetra. Then the name of NH3 amine. Then we have to name the second ligand, that is Cl here. How many number of Cl are there? 2. So we have to use the word di, that's as a prefix. Then chloro. Cl is named as chloro or chlorido. So after the naming of ligand only, we have to name the central metal ion, that is Cr here. So the name of Cr is chromium. And what is the oxidation state? When you find it out by using the X method, it is 3. So that is written in the Roman letters 3. Then so after the naming of ligand and central metal ion, at the end we have to name the negatively charged counter ion, that is NO3. How we name NO3? It is a nitrate ion, nitrate. It's not nitrite or nitride, it is nitrate, NO3. So that is named as here nitrate. I told you the number of counter ion is not specified. Still here it is only one nitrate ion. So it is named as nitrate. So this is the IUPAC name for this compound. Next we will be doing a text exercise question number 2. That is the question, write the IUPAC name of the following coordination compounds. So we will be doing these problems, that is one by one. First one, CONH3 6Cl3. We have to name this one. So as first of all identify the type of complex. It is which type of complex? It is a cationic complex. Why? Because the counter ion is negative. Counter ion is negative means the complex is positive. So we have to follow the method. First we have to name the ligand, then central metal ion, then the counter ion in the case of cationic complex. So first we have to name the number of ligand, that is 6 here. So we have to use the prefix here, that is hexa. Then the name of NH3 amine. Then the name of central metal ion cobalt. Oxidation state is written in the bracket. And at the end we have to name the counter ion. So that is the name of this complex. Second one, in this also it is a which type of a complex? It is a cationic complex because the counter ion is negative. So the complex is positive. If it is negative, this complex should be positive. Here we'll name first the ligand 5 NH3 are there and 1 Cl. I told you when more than one type of ligands are there, we have to follow alphabetic order. So amine and chlorido, Cl. So which should be named first? That is A, alphabetically order. A should come first. So that is 5 number relates to, that is penta. So number 5, the we use prefix penta, then amine. The next ligand, what is the next ligand? Cl. It should be named as chlorido because only one Cl is there. It is not necessary to write mono. Just we write it chlorido. Then cobalt. The oxidation state here, it is written in the bracket. That is 3. Next, we have to, at the end, we have to name the, that is the name of counter ion should be written at the end. That is chloride. The number of Cl is not represented here. Just we need to write chloride. Third complex, that is K3FeCN6. It is a which type of complex? It is a anionic complex because the counter ion is positive. Therefore, it is positive. Therefore, it should be a negative complex. So, in this case, we have to follow the order. That is, first we have to name the positively charged ion, that is counter ion. So what is here? It is K. K is the counter ion. So what is the name it is given? That is potassium ion. But ion word is not represented. We will be writing just potassium. Next, we have to name the ligand. The number of ligand, that is hexa. 6 it is there. Therefore it is hexa. Then cyano. That is the name of the ligand. Then ion, Fe should be written as ferrate. That is because it is which type of complex? Anionic complex. It is a anionic complex. Therefore, the central metal ion, its name should end with ATE, suffix ATE. Therefore, it is ferrate. And the oxidation number of Fe ion should be written in the bracket in the Roman letters. That is 3 here. So, that is the case of third problem. Next, fourth one. In this, here, it is also anionic complex because the counter ion is positive. So, how we name this one? That is first, the name of the counter ion, potassium. I told you the number of counter ion is not specified. It is K3, but 3 is not at all specified. We'll just write down the name of the ion, that is potassium. Then, we have to name the ligand. What is the ligand here? That is C2O4. That is oxalato ion. That is oxalato. That is in short, sometimes it is written as OX also. So oxalato is the ligand, and how many number of ligand is there? 3. So we have to use the prefix tri. Then the name of the ligand, that is oxalato. Then we have to name the central metal ion, that is ferrate. And the oxidation number here, it is 3. Now how the oxidation number, it is 3 here. Let us count it here. How we have done the method? Just recall the method. Because it is a positive ion, counter ion is there. So then when 3 positive, that is 3K plus is removed, what is it develops? It develops 3 negative charge here. So this one you have to keep X, oxidation number, that is for the case of Fe we will be writing X, and for the case of, because it has have 3 negative charge, and we know that for oxalate the charge it is -2. So how we write this one? X plus -2 into 3, that is -6. So that is -6 and is equal to -3. Because the overall charge is -3. How it comes -3? Because K, 3 positive charge is removed, then it develops 3 negative charge on the complex. So when you solve this one, so what will be X? S is equal to 3. Plus 3 is the oxidation number for Fe. So that we have written in the brackets here. So whenever you are naming any complex, the oxidation number of central metal ion, you have to find it out with the same method as we have done it as oxidation number for the central metal ion. So that is the name of this complex. Next, fifth one, K2PdCl4. What is K here? It is potassium and it is a counter ion here. How you identify counter ion? The ion which is present outside the bracket are counter ion. If it is positive, it should be written on this left hand side of the bracket, and if it is negative, it should be written on the right hand side of the bracket. So it is having a positively charged counter ion. So it is which type of complex? That is anionic complex. That is, when 2 K positive is removed, it develops 2 negative charge. So this is named in this way. That is, first the name of the counter ion, that is positive counter ion, potassium. Number 2 is not specified, just write potassium. Then we have to name the number of ligand. What is the number of ligand here? 4 Cl is there. So we have to use the prefix tetra. Then chlorido. I told you Cl can be named as chloro or chlorido. Next, Pd. Pd is which metal? That is a transition metal, that is palladium. So palladium can be named as palladate. Why? Because it is an anionic complex, so we have to use the suffix ate. For the central metal ion, we have to use the suffix ate, that is in the case of anionic complex. So it is named as palladate, and the oxidation number of this is +2, that is written in the bracket in the Roman letters. So that is about this complex. Next will be sixth part. Sixth part, when you look at here in the complex, there are 3 ligands. 3 type of ligands are there, that is amine, chlorido and methanamine. So alphabetically order, amines comes first. So we have to name diamine, chlorido, single Cl is there, and methanamine. NH2CH3 is called as methanamine, that is the name of the ligand. And then afterwards we have to name the central metal, that is platinum. It is a positive, that is a cationic complex, therefore it is the name of the central metal should be written as it is. Then oxidation state in the bracket, and this end with the suffix, it is end with the chloride. The name of counter ion is chloride. So that is the name for this compound. Now in the textbook there are some compounds like this which having the cationic and both the anionic complexes are together. So that is which type of complex? Cationic anionic complex. So this is the cationic part, this is the anionic part. So how we name such type of complexes that we are discussing here? First we name the cationic complex. In the same way we have used the rules for the cationic complex. First the ligand, that is diamine, 2 NH3 is there, diamine, then silver, and the oxidation state is 1 here. Next we have been naming for the anionic part, that is dicyanido, that is can also be named as dicyano. Then argentate. Why it is named as argentate? Because it is a negative complex, that is it is a anionic complex, so the central metal ion should be named with the suffix ate. Therefore silverate will not be used, argentate is used, and the oxidation number is written in the bracket. So this is the example that is having both cationic and anionic complexes together. Next one example we need to discuss related to EN, ethylene diamine, because the name of the ligand ethylene diamine, di word is already there. So 2 times of En means we will not use again di word. So instead of using di, we will be using bis in such case. If it is 3, then we have to use tris. If it is 4, we have to use tetra case. So that is a need to remember when we are doing with the IUPAC naming of complexes related with En. So how we name this one? This is named as, that is dichlorido. Cl is chlorido, En ethylene diamine. Alphabetically order, C comes first. So dichlorido. Bis. Why we are using bis? Because 2 times En. So bis ethane 1,2-diamine, which can also be written as ethylene diamine. It should be written in the bracket sign, as you can see here. That is, bis is for this ligand, that is ethylene diamine. Then we have to use the name for the central metal ion. Central metal ion is cobalt here. Therefore, cobalt, and the oxidation state is 3. Since here there is no counter ion, so no need to write the counter ion name, but the positive charge is there. So, we'll be using ion at the end. Usually, we'll be using ion word at the end. It shows that it have no counter ion, but it is not a neutral ligand. It having a charge. So, it is written as ion at the end. So, this is all we have discussed. Some of the examples of complexes, its IUPAC name. So, different type of examples we have practiced here. So, in the textbook, some solved problems are there. All of you try that problem, and in-text questions related to IUPAC is there. So, all of you try that questions. So, this is all about this video. Have a nice day.